Hi everyone, it's Mr. Price here to talk about long division using the train station method. But before we get started, let's review a few basics. First, division is the opposite of multiplication. For example, I know that 5 times 4 equals 20, but if you read that backward, 20 divided by 4 equals 5. Next, division is the act of splitting up a group of objects into smaller, equal groups. Look at the model on the right side of your screen. I see a large rectangle with 9 circles in it, split up into 3 smaller rectangles. Each one has 3 circles in it. What division problem do you think this model represents? That's right. It's 9 divided by 3 equals 3, because I started with 9 blue circles, split them into 3 smaller groups, which are the 3 small rectangles, and each rectangle has 3 blue circles in it. The circles here are my objects that I'm splitting up. Here are the expectations for every 4th grade student. You should be able to divide 3-digit dividends, which are whole numbers, by 1-digit divisors, with and without remainders. For example, you should be able to solve 378 divided by 7 without using a calculator. Here are a few vocabulary words that tell us the parts of a division problem. First, you have the dividend, which is the number of objects you will split up into equal smaller groups. Think about the 9 circles from the last problem. Then you have the divisor, which is the number of groups you will divide the objects between. That's the 3 smaller rectangles in the last problem. Finally, I have the quotient. The number of objects in each of the smaller groups is the answer. Sometimes you have some left over. I would call that a remainder. This is the number of objects left over after dividing evenly. The remainder should always be smaller than the divisor. Now let's look at each of these parts in an actual problem. Here's the same problem from before. 9 divided by 3 equals 3. The 9 is my dividend. That's the number of circles I started with. Then I split that into 3 small groups. That's my divisor. And each group had 3 circles in it. So 3 is my quotient, or the answer. This equation doesn't have a remainder because I have no circles left over. Here's that same problem set up as a long division problem. Now, normally you wouldn't use the long division method for such an easy problem. You could easily use your multiplication chart instead. But let's look at it anyway. This part I call the long division den. You'll see why in a second. I still have a dividend, which is the 9. It goes inside the den. I still have a divisor, which is 3. It goes outside the den. And your answer, or the quotient, goes on top as you figure it out. This problem still doesn't have a remainder, but if it did, it would go right here beside the quotient whole number. Now here's a couple of tips to help you remember which part of the division problem goes where, because setting this up can get confusing. Your dividend goes inside the den. Notice that the word den is hidden inside of dividend. Then look at divisor. It has the word visor hidden in it. I might wear a visor outside on a sunny day to protect my eyes. That's also known as the bill of the cap that you might wear. So I know that my divisor goes outside the den. Now let's look at this with a bigger problem, when I might actually use the long division den. In order to do this, you will need your multiplication chart. And remember, long division is most useful when you have to divide large numbers. Here's 378 divided by 7. Notice how the problem written this way looks different than this way. A lot of people mistake this as 7 divided by 378, but that is incorrect. When you use the long division method, you start from the inside and go out. You read 378 divided by 7. Now that I have it set up as a long division problem, I'm going to use this divisor on my multiplication chart right here. I'm going to pretend that my multiplication chart is a large train station, and each row of numbers is a train track. I'm going to be using 7 in this problem because that's what stands outside the den. So my train will be traveling along track 7 here, and that's what I'll use to solve my problem. Now each of the digits in my dividend, 3, 7, and 8, will be like my stop numbers. Let's get started. On track 7, how close to 3 can I get without going over? Well, I go to track 7 and I start traveling. Well, the closest I can get to 3 is 0. 7 is too far. I cannot go past 3. So 0 is the answer. I'm going to write whatever is here on the bottom and whatever's on the roof of the train station, that's going to go on top. So I see a 0 on the bottom, 0 on top. So I put a 0 on the bottom and a 0 on top. Once you do that, you subtract. I'm not going to worry about 7 or 8 right now, just the 3. Well, I know that 3 minus 0 is still 3. Once you subtract, you're going to drop down the next digit only. So I'm going to drop my 7 down and put it beside the 3. Now I have 37. I'm going to repeat those steps, except now I'm going to use 37. On track 7, what's the closest to 37 I can get? So track 7, let's travel. I'm good. Oh, 35 is pretty close, but 42 is too far. So that means I have to use 35. I can't go past 37, remember? So I'm going to write 35 on the bottom, and what's on top? 5. So I'll write 35 on the bottom and 5 on the roof. 35 on the bottom and 5 on the roof, right above the 7. Now, just like before, I'm going to subtract those two numbers. 37 minus 35, that's 2. Now, I'm going to drop my last digit down. This will be the last step because I have no more digits past 8 to work with. So this will be my last step. I'm going to drop that 8 down next to that 2, and I have the number 28. I'm going to go back to my train track, number 7. What's the closest to 28 I can get without going over? Let's find out. Oh, bingo. I can go right to it without anything left over or going too far. So I'm going to write 28 on the bottom and 4 on top. 28 on the bottom and 4 on top. And again, you subtract. Subtracting is the last step. Since I have nothing left to bring down, I am done. And if you had anything left over here in this triangle, that would become your remainder. But since it's 0, there is no remainder in this problem at all. So my answer is sitting right here in front of me. I don't need that 0 on the front. The answer is 54. So therefore, 378 divided by 7 equals 54. Just in case you need to see one more problem, let's do it together. I always tell my students the best way to practice division is to make up your own problems. So I'm just going to pick a 3-digit number. Let's go with 4, 9, 3. And I'm going to divide that into, how about 6? That works. So again, since my divisor is 6, I'm going to use track 6 on my multiplication chart to figure this out. That will be the train track that I use. And we're going to start by working our way inside the den. My first stop is 4. Don't worry about 9 or 3 right now. How close to 4 can I get on track 6 without going over or past it? So track 6, let's start traveling. 0, 6, oh, 6 is too much. Remember, I can't go past 4, the first digit. So the closest I can get is 0. 0 is on the bottom, 0 goes on top. Then my next step is to subtract. 4 minus 0 is still 4. Now drop down the next digit, which is 9. That gives me 49. Now I repeat those steps, go back to track 6. What's the closest to 49 I can get? Track 6, let's travel. Oh, right here. I see 48. I don't see 49, but 48's pretty close. 54 is definitely too much. So I have to stop at 48 and use that. So 48 will go on the bottom, 8 will go on top. 48 on the bottom, 8 on top, right above the 9 that I just worked with. Then subtract. 49 minus 48 is 1. Then drop down your last digit, which is 3. And that gives me 13. So now repeat the steps. I'm going to go back to track 6, get as close to 13 as possible without going over. Track 6. Oh, 12 is close, but 18 is too much, so I can't use it. I got to use 12. 12 goes on the bottom, 2 goes on top. Then subtract. Subtracting is your last step. That leaves me with 1. But I have nothing else to bring down after this 3, so I am done. And I always tell my students to write a triangle around it. I am done. There's a 1 inside this box. That's left over. Therefore, it's a remainder. So I have 82 on top with a remainder of 1. So I write that as R1. R stands for remainder. So my answer is 82, remainder 1.